Welcome to Understand the Math. In this video, we're going to learn how to graph exponential functions. We'll start with the basics and talk about shifts, asymptotes, stretching, compression, and reflections, and then graph two example problems step by step. We're going to start with the basics. There are two types of exponential functions, one that models exponential growth and then one that models exponential decay. Both of these are written as f of x is equal to b raised to the x power. When the function is growing exponentially, our base b is greater than 1, and then when our function is decaying exponentially, our base b is between 0 and 1. Notice that both of these functions have a horizontal asymptote given by y is equal to 0. Let's now look at what we call the general form of an exponential function. I've written this down here in green as y is equal to a times b to the x minus h plus k. B is our base, and it can be greater than 1 for exponential growth and between 0 and 1 for exponential decay. H and k represent shifts. H is our horizontal shift, and k is our vertical shift. Because the function is shifted vertically by k units, the horizontal asymptote is also shifted, and it's now given as y is equal to k. Let's now look at the constant a that multiplies our base b. This constant represents a vertical stretch if the absolute value of the constant is greater than 1. It represents a vertical compression if the absolute value is between 0 and 1. And then if the constant is less than 0, it represents a reflection across the x-axis. I've written down 4 steps that you can follow when graphing any exponential function. And I'm going to go through these step by step as we walk through our examples. In our first example, we are going to be graphing the function y is equal to 3 times 2 raised to the x plus 1 power minus 2. I think it's always helpful if we start by writing down the general form of our exponential equation. We talked about that general form on the previous page, and it looks like this. It's y is equal to a times base b to the x minus h plus k. The first step to graphing an exponential function is to determine the growth or decay. That is given by base b, and then the shifts, which are given by h and k, and then the stretching, compression, or reflection, which is given by our constant a. In the example that we're graphing, our base b is equal to 2, and that means we're going to have exponential growth. So we already have an idea what the curve's going to look like. Now let's think about our shifts. I think the easiest way to determine the horizontal shift is to focus on the exponential. What you can do is you can take this exponential x plus 1 and you set it equal to 0, and that's going to give us x is equal to minus 1, and then that tells us that our horizontal shift, h is equal to minus 1, is going to be to the left by 1 unit. So let's just write down shift left 1. Now let's look at our vertical shift. That is given by k. K is just the constant that's all by itself at the end, and it's equal to negative 2. And that just tells us that our graph is going to shift down by 2 units. So let's write down shift down 2. Let's now talk briefly about stretching. A, in our example, is equal to 3, which means our graph is going to be stretched vertically by a factor of 3. Let's now go on to our next step. That step is to determine which x points to plot and then create a table of values for x and y. I'm going to have to move this up, so I'm actually going to write down our function again. Y is equal to 3 times 2 to the x plus 1 minus 2. When we plot an exponential function that doesn't have any shifts in it, we usually plot the points x is equal to -1, 0, and 1. That just gives us enough points to give us the general shape of the graph. Now, we're going to have to change this because we have a horizontal shift. Up above, we found that we shift left 1. So that means our x is going to have to change, and we're going to subtract 1 from it. So instead of plotting -1, 0, and 1, we're going to subtract 1 from each of those, and we're going to plot x is equal to -2, -1, and 0. Now let's go ahead and create a table of values. We'll start with x, and we're going to plot x is equal to -2, and now we have to find out what y is. We're going to look at this equation right here, and we're going to plug in x is equal to -2, and we get y is equal to 3 times 2 to -2 plus 1, which is -1 minus 2. So this is 3/2 minus 2, and that's equal to a -1/2. Now let's compute x is equal to -1. We do the same thing for x. We plug in -1, and we get 3 times 2. -1 plus 1, I'm looking right here, is equal to 0. So we have 2 to the 0 minus 2. 2 to the 0 is 1. So this is just 3 minus 2, which is equal to 1. And we have one more. X is equal to 0. And this gives us 3 times 2 to the 0 plus 1. So that's just 2 to the 1 minus 2. So this is 6 minus 2, which is equal to 4. The third step that we can follow is to plot the horizontal asymptote. Our horizontal asymptote is given by y is equal to k, where k is just our vertical shift. And this is going to tell us that we're going to have the horizontal asymptote y is equal to -2, because we're shifting our graph down by 2 units. Before we graph our horizontal asymptote, I think it's helpful to think about what scale we want on our graph. Notice in the values that we just calculated, y is -1/2, 1, and 4. And that would definitely fit in with our graph if we make each tick mark 1 unit. So let's go ahead and let's do some labeling. This will be -2, -1, 1, 2, 3, and 4. And then we'll do the same thing, 1, 2, 3, and 4, and then maybe a -1, -2. Now we're all set, and we can go ahead and plot our horizontal asymptote. That is given by y is equal to -2. So let's go ahead and let's plot our asymptote. Now we can go ahead and put in the points that we calculated. I keep moving the graph up and down. Our first point is -2 minus 1/2, and that's going to be right here. And then we have -1, 1, which is here. And then lastly, we have 0, 4. Now let's go ahead and look at our fourth step. Our fourth step says to just plot the points from the table and sketch the graph. So you can see I kind of went out of order. I already plotted the points, but now we can go ahead and sketch the graph. We're going to start down here, and we're going to go up. And our graph looks like that. And that's it. Let's now graph another example that's going to be different than this one. In this example, we are graphing the function y is equal to 4 times 1/2 raised to the x minus 1 power plus 2. Just like we did for our first example, let's go ahead and let's again write down the general form of an exponential function. That general form is y is equal to a times b to the x minus h plus k. In our first step, we are going to look at the growth decay, the shifts, and then the stretch compression or reflection. Let's start by looking at our base, and that's equal to 1/2. So we'll write down that b is equal to 1/2, and that tells us that we have exponential decay. Now let's look at our shifts. We're going to take x minus 1 and set it equal to 0. And that gives us x is equal to 1. So that tells us that we're going to shift right by 1 unit. This is just h is equal to 1. Now let's look at our vertical shift. This 2 hanging out all by itself is our vertical shift. So let's write down that k is equal to 2, and that tells us that we have a shift up by 2 units. Lastly, we are going to look at the constant that multiplies our base, and that's equal to 4. So we'll write down that a is equal to 4, and that tells us that we are going to have a stretch by a factor of 4. Let's now go to our second step. We are going to first determine which x points to plot. Let's go ahead and let's rewrite our function. We're graphing y is equal to 4 times 1/2 to the x minus 1 plus 2. We mentioned in our first example that we usually plot x is equal to -1, 0, 1. Now we have to take into account our horizontal shift. We are shifting to the right 1. Let me go up here and let's highlight this. We're shifting to the right 1. So we're going to add 1 to all of our x values. So now we're going to plot x is equal to 0, 1, and 2. Let's go ahead and let's create our table. There's our x, and we're going to start with x is equal to 0. We are going to plug 0 up into the exponent for x, and we're going to get y is equal to 4 times 1/2 to the minus 1 plus 2. If we have 1/2 and we raise it to the minus 1, we just have to flip the fraction. So this is 4 times 2 plus 2, and that's equal to 10. Now let's let x is equal to 1. So this gives us 4 times 1/2 to the 1 minus 1, which is 0, plus 2. 1/2 to the 0 is just 1. So we have 4 plus 2, which is 6. Now we have one more to do. Let's let x equal 2. Our y then is 4 times 1/2 to the 2 minus 1, so that's just 1, plus 2. 4 divided by 2 is 2, so we have 2 plus 2, and that's equal to 4. Now let's move on to our third step, and let's plot our horizontal asymptote. So first we actually have to find it. Our asymptote is y is equal to k, and remember the k is just the constant all by itself on the right-hand side. Let me pull this down, and let's highlight that. It's that 2 right there. So this is y is equal to 2. Before we actually plot our asymptote, let's think about the scale. Notice that the values that we came up with were 10, 6, 4, and 2 for y. So those are pretty big. So I think we need to make each tick mark equal to 2 instead of 1. Let's go ahead and let's start by labeling them. We'll make this a -4, -2, and this is 2, 4, 6, 8, and 10. And then let's do the same thing for the horizontal. We'll make this 2, 4, 6, and 8, and then -2, -4, -6, and -8. Now let's plot our horizontal asymptote. That's going to be y is equal to 2, so it's going to be right here. And now we can go back up to our table and plot those points and then sketch our graph. Our first point is x is 0, y is 10, and that's going to be this point right here. And then x is 1, y is going to be 6, so that's going to be right here. And then our last point is x is 2, and y is 4. Now we can go ahead and plot our function. We're going to start up at the top left, and we're going to pick up this point, and then this point, and then we'll pick up this point, and then we're going to have to go to the right and follow that asymptote. And that's it. You've now learned how to graph exponential functions, and you have 4 steps to use as a guide. With a little bit of practice, you're going to get really good at this.
If this video has been helpful to you, please consider subscribing to my channel. Keep believing in yourself and have a great rest of your day.